for the drive so we can get. I forgot. It's math time, of course. What am I doing trying to play golf in the house? That's ridiculous. That's a little too cramped in here to try and actually swing a golf club. It's probably not a good idea. But a good idea is, again, welcome back for another day of math. We're ready for a little bit of action, but before that, the daily routine. Gotta get started with a couple things. Start with Disney pins. Why not? Up here we got a little Mike Wazowski. Oh yeah, Mike Wazowski. This Hollywood Studio pin. Right beside him, Pumbaa. Great animated sidekick. Just saying, easily top 5. Personal opinion, but it's right. But we gotta have an opening something. I got a Pokeball. Why? Because I found one. Why not? So let's see what's inside. Oh, sweet, we got Pokemon cards. Why not? And a chip of something. Of that. Do I know what this is? No, I don't. But you might, and you can let me know which Pokemon this is, because I have no clue. And a special shout out to Dane, who did know that the Little Mermaid from our last video is from the 4th Harry Potter movie. So great job, thank you. I appreciate the heads up. I like to learn a little bit too. Also, it's a card. You got a seal, but it's spelled wrong. It's weird. I'm not an English teacher, but I'm pretty sure there's supposed to be an A in there. Supposed to be a Machop. Oh, not only a Machop, we've got a Machoke. And who's this? Professor Kukui? Something like that. You got some fun stuff. Why not? All right. So we got our Pokemon cards. We've opened up something. And the Pokeball, which can go sit back up here. We'll leave the chip in there. Boom. Pokeball placed. Open up some. Oh, quotes of the day. It's time. First, our throwback quote of the day. It's from this past Friday. When I die, I want to go peacefully, like my grandfather did, in his sleep, not screaming like the passengers in his car. And our quote for today, I think is especially true. And many of you probably are living by this now with getting to the online learning kind of on your own time. The early bird can have the worm, because worms are gross and mornings are stupid. Yeah. I fully agree with that statement. All right. Quotes can go up here, hang out up top. One more thing before we get started. Grades are in, for those of you who are my students watching this, grades are in Skyward now. And so some of you are going to be really happy. And some of you might get in trouble with your parents. Just saying, if you haven't been keeping up with the work, I'm talking to you. No, not you. You. Behind you. That's the one. Get this stuff done. And if you help, again, email me. Let me know. We got to make sure we're getting all this material accomplished, because we're not only done with Part A now, we're moving on to Part B. And today starts some of those lessons for pre-algebra. Algebra, we're getting ready to do our second lesson from Part B. So I think that's it. I think it's time to get to the board. Okay, now, Magikarp, Slowbro, Raticate, Boldore. Pay attention. This is going to be on the quiz. Okay, algebra guys, it's ready. It's go time. Ready to do a little solving quadratic equations by factoring. Again, we touched on this a little bit in one of the videos from Part A, but we're going to do a little more of a focus on actually solving the equations in that process. So, solving by factoring. Right here we've got a quadratic trinomial set up. 4m squared plus 9m plus 5 set equal to 0. We learned before, using our zero product property, we can solve for m if we can figure out two things that are multiplied together to make this trinomial. So the question is, how can we figure that out? Well, if our quadratic is factorable, we can find the binomial factors, and using the zero product property, solve for the variable. But to do that, we've got to figure out what the factors are. So, as you all know, my favorite thing to do with solving these out, or with trying to find a solution here, is to use our tic-tac-toe method. to find out. Oh, we got a fire alarm, guys. Oh, never mind. It's just kidding. It's not really a fire alarm. It's just my brother cooking up stuff and burning things down. Fantastic. We're going to run through the beeping noise. I don't care. It's fine. And y'all will be cool with it too. Tic-tac-toe time. Turn that off! Thank you. Ah! It's fine. Here we go. 4m squared goes in our top left corner. 9m, or our bx term in this case, is going to go in the bottom little extra box we've got. And in the top right corner, we're going to put, or sorry, in the middle corner, we put 5. In the top right, we're going to multiply across. 4m squared times 5 is 20m squared. Now we've got to figure out two numbers. And I'm going to give you a hint here. There's going to be something with times m. Two numbers that multiply to equal 20 and add up to equal 9. So we can come up with a factor list if we're not sure. So we know 20 times 1 equals 20, but if I add those together, they don't equal 9. 10 times 2 also multiplies to 20, but again, the sum there is 12. Well, 5 times 4, that works. 5 and 4. Now, we look at our corners here. 4m squared and 4m. What's the greatest common factor of those two numbers? Well, 4 and 4, the greatest common factor is 4. M squared and m, the greatest common factor is m. Multiply up. 4m times what equals 4m squared? Yeah, yes. Yeah, m. Now we got to fill in these middle boxes. Do that by multiplying across. 4m times something equals 4m. What is it? 1. It's just 4m times 1 is going to equal itself. And m times 5 equals 5m. Here's the fun. We're going to do a little, there's one time you can actually do a little crisscross action here. We now have two binomials multiplied together that will equal 0, which means we can use our zero product property. So either m plus 1 equals 0, or 4m plus 5 equals 0. Well, if m plus 1 equals 0, what number plus 1 equals 0? Negative 1. 4m plus 5, we subtract 5 from both sides, divide by 4, get negative 5 over 4. So these are the two values for m that would make this equation true. Over here, we got 6r squared minus 15r minus 99 equals 0. Well, we could go straight to tic-tac-toe, but I noticed something here. There, 6, 15, and 99. Those are all multiples of 3. We all like using smaller numbers if we can, right? It's always better. So if I divide both of my equations, or both sides of the equation by 3, 0 divided by 3, still 0. We'd have 2r squared minus 5r minus 33 equals 0. Again, we don't have to do that. We would still end up with the same answers if we used the original equation, but we all like to make things simpler if we can, right? So now, 2r squared minus 5r minus 33. We know that two binomials multiplied together will equal this, since it's factorable. So let's go tic-tac-toe. Again, our first term, our ax squared term, in this case 2r squared, goes in the top left-hand corner. I'm going to get a slightly darker marker here. Don't tell Mom I did that. We put negative 33 here, and the bottom we put negative 5r. It's important to make sure we keep those signs. It says negative 5r, this is negative 5r. Multiply together here, negative 66 r squared. We've got two numbers that are going to multiply to a negative number and add up to a negative number, which means one of my factors has to be negative. And since my sum is a negative number, it means the bigger of the two has to be negative. So let's list out our options here. We're getting negative 66 times 1. Does that work? No, does not add up to negative 5. You do negative 33 times 2. Negative 22 times 3, no. But negative 11 times 6 will work. Negative 11 plus 6 is going to equal negative 5. So we've got our two numbers here. We're ready to move across the board. 2r squared and 6r, the greatest common factor, b. 2r and 2r times r equals 2r squared. Now we multiply across. R times what equals negative 11r? Negative 11. 2r times 3 will equal 6r. So now, across r plus 3 and 2r minus 11 are my factors. So now we're just going to solve for r. We've got two things multiplied together that equal 0, so one of them has to be 0. So either r plus 3 equals 0, or 2r minus 11 equals 0. R plus 3 equals 0, that means r could equal negative 3. 2r minus 11, we add 11 to both sides, divide by 2, we get 11 halves, or 5.5. Okay, again, this process is pretty simple. We're going to look at a couple more examples in just a second, and then we'll be wrapped up for today. Be back in just a moment. More math. Hey, give me 5, give me 5. Get up, get up, hey, no, up, 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 up. There you go, get down, get down. Bang, 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 bang.
Close enough.
That works. That'll make its way into 2 down. 3 more to go. We're going to do these two because they're kind of similar. These are some, we call special case trinomials. Why do we call them that? It's because they're special, of course. Y squared minus 12y plus 36 equals 0. Now, we can go through our tic-tac-toe method that we just learned, or you can factor it out if you know and want to work it out that way. But I noticed something special here. I've got a perfect square as my ax squared term, but I also have a perfect square here. 36 is a perfect square. It's 6 squared. And this middle term here, negative 12y, well, that's 2 times the square root of 36 times the square root of y squared. So we can't go through all the work for this, but because this is a special case and I recognize some of this information, we know that this is y minus 6 squared. Okay? By knowing that rule, again, it's because we got perfect square and ax squared, perfect square for c. And our middle term here is the product of 2 times the square root of y squared times the square root of 36. Now, because it's negative 12y, we have a minus sign, be minus 6. And how many solutions are we going to have here? Yeah, just one. Because really, this is another way of saying this is y minus 6 times y minus 6. That means either y minus 6 equals 0 or y minus 6 equals 0. It sounds like I'm repeating myself. Well, if y minus 6 equals 0, then y equals 6. Again, another similar example here. 9x squared plus 12x plus 4. Again, I've got a perfect square here because 9x squared is really 3x times 3x. And 4 is a perfect square as well. It's 2. Is 12x equal to 2 times 3x plus 2? Yeah, it is. So another way I can write this trinomial is, as its factors, which would be 3x plus 2 squared, which again is just saying 3x plus 2 times 3x plus 2. Well, I gotta solve it once. There's no reason to do extra work if we don't have to. So 3x plus 2 equals 0, which means x equals negative 2/3. Yeah, we can go through tic-tac-toe for this. We can, but we don't have to. If you know some of those rules, if you notice that this is a special case trinomial, we can do a little shortcut. All right. One more problem, and we're out for the day. Again, as always, coming together for math every day, every one of these times we do these videos. And even though we're going to do a family meeting later today, because it'll be family meeting time. It'll be family meeting time, which is going to make them cringe if they're watching this, because memories. Anyways, again, to my siblings, I'm going to point them out for you today. Anthony, Ross, DJ, get out of the way. We gotta find Rebecca and Rebecca and Nelson didn't show up today. What? Stupid. I'm just kidding. I love y'all. I found them. They were hiding here behind Jim and Pam and Mufasa because that's a thing. Hang out with the American flag. Hey guys, how's it going? Cool. All right, last problem here. We've got another quadratic equation we're going to solve. We've got negative 3t squared equals negative 108. Now, that's great and all. We know we've got to have our equation set equal to 0 so we can use our zero product property. So the first thing I need to do is add 108 to each side of this equation. So negative 3t squared plus 108 equals 0. Now, I want to do one more thing here. So I like to have ax squared, this term here. Yeah, I want a positive coefficient. So to make that happen, I'm just going to divide the whole side, left side of the equation and the whole right side of the equation by negative 1. Which means I've got 3t squared minus 108, not 180, equals 0. Now, I notice again, I've got 3 and 108 here, these numbers. 108 and 3 are both multiples of 3, so do one more step here. Let's divide both sides of this equation by 3. We get t squared minus 36 equals 0. Unlike the other equations we've had so far, I've only got 2 terms here. There's no bx term. So I've got t squared minus 36 equals 0. I do know, though, that t squared is a perfect square and negative 36 is a perfect square. So because, again, a special case, we actually know this means that if I factor this down, it's going to be t plus 6 times t minus 6. We know that bx term is going to cancel out. So we've got our factor. We could have gone through the process of trying to use tic-tac-toe, but because I see it's a special case, I don't have to. So that means either t plus 6 equals 0 or t minus 6 equals 0. Well, what number plus 6 equals 0? 6. And what number minus 6 equals 0? 6. How about that? Able to factor these things down. It's all about, remember, again, whole goal here. We've got to set the equation equal to 0 so we can use our zero product property after factoring. Man, I feel like that's a whole lot of lesson. We'll be back with the closing in just a second.
Many months later.
Again, more math, more algebra, another great day. I want to highlight here some other friends that showed up today. Say hello to COVID Minnie and COVID Mickey. Here, just to remind you, for the Outbreak 2020, wash your hands. Wash them. I know you learned it a long time ago. Seriously, wash your hands. It's gross if you don't. We're basking in some algebra glory here. Let's be real. It's pretty awesome. The son of the teacher of the universe, the Algebra 1 champ, here again for another day. Tomorrow's going to be another good one. So, all I'm saying is we'll see you tomorrow, but be ready for some more math. Get your work done. See you soon.